Chemical reactions, types, rates, and energy. We have only started scratching the surface of chemical equations, and I'm sure already you can see through numbers of examples you've dealt with is that there are all sorts of chemical reactions. Millions of chemical reactions are happening all around us and inside us even every single day. So scientists have been able to categorize some of them into types of chemical reactions. Some of the four most common types of chemical reactions are synthesis, decomposition, single displacement, and double displacement. Now, when I think of these categories of chemical reactions, I like to picture the substance of the equations like going to a dance. One of the easiest reaction types to recognize at this quote-unquote dance is a synthesis reaction. Well, it wouldn't be a dance unless we started getting couples together to dance, right? So in a synthesis reaction, when two or more substances combine to form another substance, this is synthesis. As you can see here in the example, substance A combines with substance B and forms compound AB. Now, let's say that this wonderful couple is dancing and they just find they are not compatible and decide to go their separate ways. Well, this is called decomposition, which means to break apart, right? A breakup. A decomposition reaction is the reverse of synthesis, and instead of two substances coming together to form a third, decomposition occurs, and when that substance breaks down into two or more substances. So we had the wonderful couple AB, and now they have broken up back into singles, substance A and substance B. Now we know couple AB are not the only two substances at this dance, right? Well, if substance A happened to see substance B dancing with the substance C, well, I think A might become a little jealous and maybe just step in and say, hey, I'll dance with C. Or A might step in and say, never mind, hey, listen, B, we shouldn't have broken up in the first place. Let's get back together. Well, this silly analogy is how I picture single displacement reaction, where one element replaces another element in a compound. So in the example, you can see atom A displaces atom B to produce a new molecule AC. And A could also easily displace atom C to produce an AB molecule. And finally, in our double displacement reaction, we really just find out that we've been at a square dance this whole time, and when partners, they're just promenading each other, do-si-doing, and doing so with the other partner. So as you can see in a double displacement reaction, one compound, a positive ion, will replace the positive ion of another compound in order to form two new compounds. So here you can see, looking at our example, atom B has now replaced atom C. They just swapped partners to form two new compounds. Synthesis, decomposition, single and double displacement are just a few classifications of chemical reactions. There are other types of chemical reactions also happening all around you. A common one is when you see something rust, or maybe when something explodes like a firework. This is called a combustion reaction. And a combustion reaction occurs when a substance reacts with oxygen to produce energy in the form of heat and light. But a combustion reaction can also be a synthesis reaction. Other reactions include energy exchanges. And whether a chemical reaction is happening over a long period of time, like rust, or quickly, like an explosion, these reactions are releasing or absorbing energy. Energy can take many forms, such as heat, light, sound, or electricity. The source of this energy is in those chemical bonds we talked about. And when chemical reactions take place, chemical bonds are broken, and in order to break these chemical bonds, it requires energy. So therefore, in order for products to be produced, new bonds must form, and bond formation releases energy. When energy is given off and the reaction is primarily in the form of heat, the reaction is called an exothermic reaction. Burning of wood or the explosion of a firework is an example of an exothermic reaction. Even rusting iron, like on a bike, is exothermic, but since it happens usually very slowly, it's difficult to detect any temperature change. Sometimes a chemical requires more energy to break bonds than is released when new ones are formed. And when the energy needed is in the form of heat, the reaction is called an endothermic reaction. If you've ever had to use an ice pack on a swollen ankle or a swollen eye, you've probably noticed that when you broke that ice pack, it became very cold. Well, the ammonium nitrate crystals in water, which are inside an ice pack, actually absorbs all the heat energy from the surrounding environment, making it cold. This is an endothermic reaction. We've also through here talked about that speed of reactions, and somehow some move fast, some move slow. Well, some chemical reactions actually proceed too slowly even to be useful. So in order to speed them up, we add something called a catalyst, which is a substance that actually speeds up a chemical reaction, but it doesn't change the product itself. If a chemical reaction needs to be slowed down, then something called an inhibitor is used. This might be, for example, a preservative added to dough when making bread. Preservatives are inhibitors that prevent spoiling of that bread. When using catalysts or inhibitors to change the speed of reaction, one thing to understand is that they do not change the amount of product produced, only the rate. All right, we have now completed this section, so it is time to show what you know.